Hi, my name is Molly Goldman, and today I'm going to be talking to you about hydrates. What they are, what their properties are, and how you can use them in a problem. On this slide, I'm going to be talking to you about what hydrates are. The definition of a hydrate is an ionic compound with loosely attached waters. An example of a hydrate would be LiNO3.3H2Os, and this whole thing would be the hydrate. Another thing you get when you deal with hydrates is an anhydrate, which is the same thing as a hydrate, but it doesn't have the attached waters. An example of this would be just LiNO3. In this slide, I'm going to be teaching you about some of the properties of a hydrate. The first one is that it has waters that are loosely attached. Also, you can remove the water with heat, and you can add the water by exposing it to moisture. One way you can use hydrates in a problem is called percent by mass. This problem has three parts. The first one is a word problem. There was an experiment where the mass of a hydrate is 4.533 grams. After heating it, the mass of the anhydrate is 4.02 grams. What is the experimental percent of water by mass in the hydrate? The first step to solving this problem is to make a list of all known numbers. So, you got from the problem that your hydrate equals 4.533 grams, the anhydrate equals 2.042 grams, and the water is what we're trying to find. In the second step, we're trying to find the mass of the water. So we subtract the mass of the anhydrate from the mass of the hydrate. 4.533 grams minus 2.042 grams gets you to the mass of water, which is 2.491 grams H2O. In the third step, we're going to use the equation water over hydrate to find the final answer. Water over hydrate equals 2.491 grams H2O over 4.533 grams, which gets you 0.5495 grams. In the fourth part, we're going to multiply the answer by 100 to get it into a percent form. 0.5495 times 100 equals 54.95% mass of water. The second part of this problem can be a little bit more challenging. If the hydrate in the last problem was LiNO3.3H2O, what is the theoretical percent by mass of the water in the hydrate? The first step is to find the mass of all three things. And to do that, we're going to use the periodic table masses. Lithium equals 7 grams, plus N, which equals 14 grams, plus O, which equals 16 grams. But since it's O2, we need to multiply that by 2. And this gets us 69 grams, which is the mass of the anhydrate. Next, we're going to do the mass of the water. So we're going to do H, which equals 1, but it's H2, so we need to multiply that by 2. O, which equals 16 again, and we're going to add those up to equal 18. But since there's 3 H2Os, we want to multiply 18 times 3, which gets us the final answer of the water, which is 54 grams. Next, to find the mass of the hydrate, we're going to add 69 grams plus 54 grams, which gets us 123 grams. Step 2. We're again going to use the equation water over hydrate to get a final answer. So we're going to take 54 grams over 123 grams, which equals 0.4390 grams. And in the third and final step, we're going to multiply our answer by 100 to get it into percent form. So we're going to take 0.4390 times 100 to get 43.93% mass of water. Excuse me, I meant 43.90% mass of water. So in the final part of this problem, they're going to ask for the percent error. The equation to finding the percent error is the absolute value of experimental minus accepted over the accepted value, all times 100. Now, the percent error is very useful for determining the precision of your calculations. So the first and only step to doing this is to plug your answers in to the equation. So we're going to plug in the absolute value of 54.95 minus 43.90 all over 43.90 times 100. And that gets us the answer of 25.08%. Thank you for watching. I hope you learned a lot about hydrates.